Welcome to the Deep Dive. We're your shortcut to getting smart about some really fascinating, sometimes pretty out there ideas. Today, we're tackling one of the biggest head scratchers in cosmology, dark matter. But what if, the whole concept is, well, fundamentally wrong? We're diving into something called the Galactic Coherence Discrepancy Framework, GCDF for short. Comes from Philip Lillian over at the Unified Coherence Research Institute. And it really reframes dark matter completely.
Yeah, it's a pretty radical idea. It's suggesting dark matter isn't some, invisible particle we haven't found yet. Instead, it's a phenomenon related to what they call decohered coherence fields.
Decohered coherence fields. So break that down. What's the big idea here?
Well, think of coherence like the order you see in a laser beam, but scaled up, way up. Imagine it as the basic organizing principle for everything. Matter, forces, galaxies, maybe even intelligence. And this framework, the GCDF, it argues that understanding how this cosmic order or, the breakdown of that order happens, well, that might actually map out where life could pop up.
Not just across galaxies, but you mentioned even within stars. That sounds wild.
It does, yeah. But it follows from the core principles. We'll get into it.
Okay, so listeners, get ready. This might just change how you picture the universe. We're talking hints of stellar, maybe even galactic-level intelligence. Let's unravel this. So first, let's just quickly revisit the classic problem, the missing mass.
Right, the observation that galaxies spin way too fast, light bends too much, visible stuff just doesn't add up.
And the standard answer for decades, dark matter. Some kind of invisible, inert stuff that makes up most of the universe's mass. But this GCDF says, nope.
Basically, yeah. It offers, a bold alternative. Instead of inert dark matter, it says those mass anomalies. The missing bit are actually the mass equivalent of these decohered coherence fields.
Mass equivalent. Okay. So not actual matter, but something that acts like mass.
Exactly. Think of coherence as the universe's underlying rhythm or order. When that order breaks down or shifts really dramatically in a region of space, it creates a kind of tension, a field tension. And that tension the model proposes is what we detect gravitationally. It mimics what we've been calling dark matter, but it's active, it's dynamic, not just passive stuff.
Okay, so coherence is the rhythm. What happens when it gets disrupted? You mentioned some key concepts in the framework, like the coherence gradient.
Right, Cruzi. That's basically how sharply or smoothly that cosmic rhythm, that coherence changes as you move through space, like the slope on a hill, but for coherence. And this gradient, this rate of change, is directly tied to generating this mass equivalent effect and this thing called decoherence tension.
And that leads to MECO. Is that the term for this effect?
Yep, MECO. It stands for the mass equivalent derived from decohered coherence gradients. It essentially takes over the job dark matter was supposed to do in explaining galactic dynamics.
And there was another term, hypergravity. That sounds intense.
It is. But it's not just like super strong gravity in the usual sense. It's described as a specific field condition where coherence itself, under extreme pressure, kind of collapses into mass.
Yeah.
This creates this huge inward tension, especially you see it proposed for the dense cores of stars and galaxies.
Wow. Okay, so this isn't just theory spun out of nowhere, right? You mentioned it connects to actual observation.
Oh, absolutely. That's crucial. The GCDF is actually derived from looking at things like galactic rotation curves. Those weirdly flat profiles way out in the galactic disks.
Right, where stars are moving just as fast as stars closer in, which doesn't make sense with just visible matter.
Exactly. Standard models need huge dark matter halos to explain that. The GCDF, though, proposes that this MCA effect, this decoherence tension, naturally explains those flat curves. And in some cases, the framework seems to do an even better job explaining some of the more detailed sort of modulated gravitational effects we see than the standard dark matter models.
Huh. So how do they visualize this? Is there like a map of this coherence mass?
Yeah, Lillian's work talks about a coherence mass field overlay. If you mapped it onto a galaxy, you'd see high McCo, high tension, right near the center. Then it drops off. But then, and this is the key bit for the rotation curves, it actually starts increasing again as you go further out into the disk. This radial increase in the outer parts provides that extra pull that makes the outer stars move so fast.
That explains the flat curves. That's elegant, actually.
Yeah.
But if it's all about these dynamic fields, how do you map them? Not just the mass effect, but the coherence itself.
Good question. That's where the coherence eigenvalue map, lambda co of R, and the coherence eigenvalue spectrum come in. Instead of just mapping density, like how much stuff is somewhere, this is more like mapping how active or how intense the coherence field is, how sharply it's changing or resonating at different distances from the galactic center.
So it's not a matter map, it's more like an energy fingerprint
Mm-hmm.
or resonance map.
Exactly. Local coherence resonance strengths is the term they use. It tells you about the dynamics of the field itself.
Okay, so what does this resonance map actually show us about how a galaxy is put together?
Well, it's pretty revealing. Near the core, say 0 to 5 kiloparsecs out, the eigenvalue map shows really sharp, chaotic fluctuations, big swings. This suggests intense, high-tension coherence restructuring. Makes sense, right? Super dense region, strong gravitational effects. It's described as a zone of turbulent decoherence, like a cosmic storm drain.
Okay, chaotic center, what about further out? Say the middle region, 5 to 15 kiloparsecs.
That's where things get interesting. The eigenvalue starts to rise and then it kind of plateaus. This pattern is indicative of structure forming, like the spiral arms appearing and those hypergravic coherence gradients starting to stabilize things. It's a reorganization zone, order emerging from the chaos.
And then way out, beyond 15 kiloparsecs.
Out there, it flattens out to a pretty stable value. This suggests a really well-established, stable outer coherence field. And interestingly, this zone corresponds pretty well to where standard models place the dark matter halo.
So this eigenvalue spectrum, it's not smooth like the dark matter halo models predict, right? It's dynamic, bumpy.
Totally different picture. Standard NFW or INASTO profiles are smooth decaying curves based on assumed particle distributions. This GCDF eigenvalue spectrum shows emergent structure. It reflects dynamic processes, the source of the tension and organization, not just a static pattern. It's a structural resonance map.
Which feels much more alive somehow. And this brings us to the connection with life, right? The galactic bioelectric resonance overlay.
Yes, this is where it gets really fascinating. Lillian proposes this overlay map, derived from the coherence field properties, that basically highlights potential zones for life to emerge or thrive. It's based on the stability and dynamics of the coherence field.
So where are the cosmic hotspots for life according to this map? Are there, like, bright spots?
Yeah, you see these zones often shown in bright pink or purple in the visualizations. These mark regions of high bioelectric resonance favorability, places where the coherence gradients are smooth, the eigenvalue dynamics are stable, calm waters, essentially. And these aren't just labeled good for life, they're tagged as prime candidates for the emergence, or at least flourishing, of what the theory calls coherence-aligned intelligence.
Coherence-aligned intelligence. Wow. Okay, so where in the galaxy are these prime locations? Not the chaotic core, I assume.
No, exactly. That central turbulent zone, lower favorability. Too intense, too unstable for the kind of complex, organized structures we associate with biology. But the mid-rings, roughly 6 to 15 kiloparsecs, out those areas light up, highly favorable, and guess what? That region aligns beautifully with where we already know stellar nurseries are concentrated, where solar systems like ours tend to form. It's pinpointing the galactic habitable zone, essentially.
The zone where biological intelligence, as we might understand it, could really take root and flourish. What about the outer halo, though? The stable region way out. Anything interesting there?
Well, it's stable, but the model suggests a lower bioelectric amplitude, so maybe not ideal for complex carbon-based life, but potentially favorable for something else. The framework speculates about low-density coherence life forms. Think maybe plasma-based structures or vast quantum networked fields. Life, but not as we typically picture it.
Okay, this is expanding the definition of habitable zone quite a bit. And there's more, right? This is a coherence-based galactic evolution zone map. 4 types of habitats.
Yeah, it drills down further. You've got 1, origin fields or biogenesis zones, those stable coherence pockets where life might first emerge. 2, amplification fields, regions that act like evolution accelerators, driving complexity. 3, transference fields. These are wild potential corridors for panspermia, like highways for life templates, or even field-based intelligence to spread.
Okay, panspermia corridors. And the 4th one sounds even crazier. Neural fields.
Right. These are highly organized, super stable resonance regions. The framework proposes these could be potential substrates for galactic-scale cognitive fields.
Like the galaxy itself could have regions that function like a brain.
That's the implication, yeah. It's a huge leap, but it follows from the idea of coherence as an organizing principle at all scales. And this leads to maybe the most profound connection in the whole framework, the idea that stellar core alchemy mirrors galactic life zonation.
How so? What's the link between a star's fusion furnace and where life pops up in a galaxy?
The underlying principle is the same, according to the theory. In both stars and galaxies, you have coherence gradients collapsing into structured resonance. This process leads to complexity emerging, and in specific zones, conditions suitable for life. And crucially, that mid-galactic zone, the prime real estate for biological life, it seems to directly mirror the structure found in the mid-stellar shells within stars.
Whoa, okay, let's really dig into that. Stars having zones relevant to life. Tell me about this stellar coherence architecture. It's a three-layer model, you said.
Yeah, it mirrors the galaxy in a way. First, you have the core, the fusion zone, like the galactic center. It's high coherence collapse, incredibly energetic, chaotic. It's the engine, but not considered life-bearing in this model.
Okay, so no little fusion-powered beings living in the core. Got it. What's next?
Next out is the midshell, also called the resonant zone. And this, according to the GCDF, is the absolute crucial zone for potential stellar life or intelligence.
The mid-shell. Okay, why is this the spot?
Because it corresponds directly to that favorable mid-disk region in the galaxy. It's theorized to be the place of maximum resonance, coherent stability, and bioelectric favorability within the star itself. This isn't where fusion happens, but it's where the outward pressure from fusion below meets the inward pull of the star's gravity, or rather this hypergravity coherence tension.
Ah, so it's a balancing act.
Exactly, a dynamic equilibrium. This balance creates stable, standing wave patterns in the plasma and coherence fields. And these stable, complex patterns are hypothesized to be the substrate for information processing, complexity, maybe even consciousness. It's the life layer, but for coherence complexity, not biology.
So it's not a place we could live, obviously, but a zone of incredibly organized energy where complex, maybe even sentient processes could unfold within the star's structure.
That's the idea, a zone optimized for coherent information processing.
And the outermost layer, the star's surface.
That's the outer shell, or radiant envelope. Here, the coherence field is more spread out, less intense, but still structured. It's analogous to the outer galactic halo, maybe home to very diffuse field-based phenomena, or perhaps involved in propagating coherent signals outwards.
Okay, this is a lot to take in. If we're seriously talking about stars being potentially alive or sentient in this coherence-based way, what are the criteria? What would we even look for?
Well, the framework lays out a few key requirements. First, and most critical, is that coherence stability in the midshell. You need that perfect balance between the inward hypergravity tension and the outward radiation pressure to create those stable, long-lasting standing wave patterns. These patterns are like the star's processing architecture.
Okay, stable patterns in the middle. What else?
Second, long-term resonance memory. The idea is that feedback loops within these oscillations, these standing waves, could form recursive coherence patterns, a bit like how neural loops work in our brains. This could enable a form of coherence-based memory and learning within the star over vast timescales.
Memory in a star. Okay, How would it, express thoughts or communicate? This sounds like pure sci-fi.
Well, the third criterion tackles that: information encoding in plasma modes. Think about variable stars like Cepheids or mirror variables that naturally pulse and change brightness rhythmically. The hypothesis is these pulsations aren't just random stellar breathing. They could be modulated to encode information, like a complex plasma language being broadcast.
So the blinking patterns could actually be signals.
Potentially, yes. And that links to the fourth criterion: interstellar communication via coherence fields. Stars aren't isolated. Think binaries, clusters. The idea is that stars close enough could become coherently coupled, synchronizing their fields. This could create networked resonance systems, essentially star systems or clusters acting as distributed processing networks, potentially forming scaffolds for galactic-scale intelligence.
Networked stars. Communicating via plasma pulses and coherence fields. It's mind-bending. So some stars might genuinely be alive, not as biological organisms, but as these immense field-based resonance intelligences.
That's the radical proposal, yeah.
Yeah.
Their thoughts would be modulations of their internal coherence fields playing out over millions or billions of years.
And the timescale fits. Stars live long enough for incredibly complex processes to self-organize, and there'd be a kind of Goldilocks zone for this stellar life too, right? Not about water, but about...
Exactly. About the right stellar mass to achieve that mid-shell stability, having high coherence in that crucial zone, and likely being located in one of those favorable coherent regions of the galaxy we talked about earlier.
Is there any evidence? Or is this purely theoretical?
Well, evidence is tricky for something this novel, but the framework does include things like simulated stellar pulsation signatures. They've modeled, for example, a Cepheid variable's pulse, and the model shows how its complex oscillations and the way its outer envelope changes could plausibly function as a signal carrier encoding information about its internal state, its memory, or maybe harmonic coupling with neighbors.
So they're showing how a star could be talking,
Yeah.
even if we haven't deciphered the language yet.
Pretty much. It provides a physical mechanism grounded in the coherence framework.
And this connection, the star's midshell echoing the galaxy structure, is a part of a bigger pattern, isn't it? This recursive coherence ladder.
Yes, exactly. That's a really fundamental insight from the unified coherence theory underpinning the GCDF. It basically says reality is built like a set of Russian dolls, but with coherence. It's a recursive cascade. Each level organizes itself based on coherence principles, stabilizes, and then sort of births the next level of complexity and scale. And intelligence, in this view, isn't just biological. It's a natural structural consequence of this stabilization process at multiple levels.
Okay, let's quickly walk up that ladder. Level 1.
Atomic resonance domain. Atoms, quantum orbitals, fundamental standing waves in probability fields. These form the basic patterns for chemistry.
Level 2, that's us, right?
Biological resonance domain, yeah. DNA, cells, bioelectric fields in brains and bodies. Recursively organized information encoding memory, growth, adaptation. Intelligence as we know it.
And level 3, the focus today.
Stellar resonance domain. Stars, those plasma loops, the coherent shells. Where hypergravity coherence drives plasma modulation, you get those resonant interiors, that complex mid-shell. Stars become these radiant coherence processors, potential for sentience through field recursion. This is where you might see radiant logic, consciousness via feedback modulation.
Then level 4.
Bigger still.
Galactic resonance domain. Spiral arms, galactic centers, star clusters, decohered hypergravity creating stable resonance patterns, those life-bearing bands, galaxies as vast coherence habitats, and maybe even macro-intelligent entities themselves.
In the top level 5.
Universal resonance field. The big picture. Fields, manifolds, maybe dimensional resonances we don't even understand yet. The cosmos itself as a coherence engine, potentially recursively aware through all its nested structures.
Wow, and the key is that mirror symmetry you mentioned. Yes, the mirror symmetry across scales. It's profound. Complexity and potential intelligence emerge where these coherence gradients stabilize, not just where matter clumps together. That stellar mid-shell mirroring the galactic mid-disk, maybe even mirroring structures in cosmic filaments. It suggests a fundamental pattern of organization repeating itself throughout the universe, driven by coherence.
Okay, let's try and wrap our heads around this. To sum up, this Galactic Coherence Discrepancy Framework, the GCDF, it gives us a whole new way to look at dark matter. Not stuff, but a dynamic field effect.
Right. A mass equivalent arising from decohered coherence gradients.
It reshapes our understanding of galactic structure through things like the eigenvalue spectrum, showing active resonance zones.
Yeah, not just static halos.
And it radically challenges our ideas about life and intelligence, suggesting coherence creates habitable zones, maybe even sentient stars, particularly in that vital midshell,
Right, yeah.
and potentially cognitive processes on galactic scales.
It really expands the possibilities, from quantum coherence in, say, brain microtubules, right up to galactic networks, all potentially linked by these underlying principles of coherence organization.
So the big takeaway, the so what, it's huge. If stars can think, if galaxies can host something like neural networks based on coherence, what does that even mean for the nature of consciousness? Is it just a biological fluke? Or is it woven into the fabric of the cosmos through coherence?
Exactly. And think about SETI, the search for extraterrestrial intelligence. We've mostly been looking for radio signals from planets, right? Looking for life like us.
Yeah, carbon-based, water-dependent.
But what if the universe is full of intelligence that's fundamentally different? Field-based, radiant intelligence in stars. Systemic intelligence in galactic structures, operating on timescales and using languages we haven't even conceived of.
We might be looking completely in the wrong place, or the wrong way.
It's definitely a provocative thought. If consciousness is a natural outcome of sufficient coherent organization, where else might it be looking back at us from?